So I'm just trying to share. I don't know where I tend to share my live streams. Where do I normally tend to share my live streams? Let's go into the work in progress. Also, sorry Francis, because this is not probably going to be part of my reel, but either way, I'm still going to do it. I already started out with some code. Let's reset it and let's just start from scratch, because the code that I have inside this file here doesn't exactly work. So this is making structures and some variants of functions. These are all the functions that I need to implement as well. But I'm going to recreate all this inside another setup. But for now, I want to take a look at my TechUp project and figure out how I did this, because if I jump back up into my folder here, I had a few specific setups for it. So I had scenes. Let's look at my one of these would be a scenes. My Navier-Stokes scene would be it, which this is just the scene file, so it doesn't exactly show you much. But what I'm looking for is I want to figure out what I was doing inside it. So I've got a compute solver here, which I was trying to port the fluid solver over to the GPU, and I didn't exactly manage to make that one in time for the assignment. However, this is the fluid solver here, and I had a grid system, and I had so basically what I did is I had a start method where from memory, start in Unity is like on the first frame. I should technically make sure that's correct. Pretty sure it is called on frame when the frame, yeah, on startup. So this is the startup frame, and I create all these components. So I'm making a render texture. A render texture is basically a texture that I'm going to be rendering something to. I enabled random write because I needed to access it. I didn't want to access it per point. I wanted to access it randomly, I believe. And I just created it. Then I made a component renderer, and I set it to the texture and to the material, and then I set everything there. Then I made a small grid, and that's what I needed. So next what I did is I had a mouse position in the update. This is the update loop, where I had a ray that was shot from the camera to the world, so you couldn't move. So when the scene was played, you couldn't move the camera. And what I would do is I would then remap my mouse position, X and Y, and I would say, hey, if I am pressing on my mouse in this step here, if I'm pressing on it, then I just want to add density to these two positions. And I had to cast, because these are float values, because yeah, these are float values, and I had to add a density of 1 at those 2 points, and then I had to add a velocity, which was so mouse pos and mouse pos 0 is this was the original the frame beforehand position, so I could tell where my velocity should be going through to. And then I would then do a step, and I would render, and the step is going to happen every frame. So all this has to happen every frame basically, and then I'd render it. The render node basically read all the pixels from the array that I had here, and it would set it up like that. So with this one, it's got this beautiful thing called array index, which is pretty easy to find. It's basically we're just trying to figure out which where the point is that we're currently located, or basically the point where we're located on in the array that we're going to have. It's probably being a bit easier to show you, but I'd have to download Unity, and I don't think I have Unity installed. I do not. But I'll try and go through it as best I can. So let's just lay down a geonode, and let's grab an attribute wrangle, and this code is going to get quite big. So in my other node, maybe groups. Okay, someone's got an actual question in about something, so I can't really help with right now. Where am I? So in my other code here, we can see that I have a secondary outer code section, and this is actually this VEX part here is actually registering from here. The reason I do that is because for some stupid reason the struct keyword does not work. Just doesn't work inside of this VEX, which if you look at the documentation, it should. So my fix was to go to the edit parameter interface, and hang on, I better just check, and I have to actually open up the VEX node for this as well. I have to dive inside here and dive inside here, and we can see it's got this outer code expression here, which is what I need to link it to basically. So if I just quickly look at my other one, so I'm going to go jump back up into here, and I'm going to make an edit. I'm going to go edit parameter interface. I'm going to get a string, and I'm just going to plug it into there. I'm going to call it outer code. Outer code. I'm going to hit apply for now. I just want to save my document. I'm going to set a project actually. So I don't need most of this stuff. And so this was just projects, and this was just going to be called fluid VEX solver. And I'm being very ambitious, I know that. So actually no, I don't need to set it now, I just need to say job. I am being pretty ambitious with trying to get this all done in like maybe a day. But we'll see how we go. So we need to actually tell it what type this node is. You can see it's got like the script callback, which is like, oops, I moved it. Oh, come on. The script callback here, which is the language. We don't want that, so I'm going to get rid of it. And I need to do a few things. I need to turn on multi-string first. I'm going to say 8 to 40, that's fine. I'm going to hit apply. We're going to see it's an editor now. Basically, that's all I really needed to do. Last time I actually went ahead and made like all these specific things set up as well. That's fine. So now what I need to do is I need to copy this parameter, dive inside here, and I need to paste this as a relative reference. I'm just going to quickly check on that. Yep. And that's basically all I need to do. If I jump back up, you can see it's kind of working now. So if I chuck it into here, now it'll work. I'm going to add a point, so it's at least going to be run once. Even though it's set to detail, it'll run anyway. I can now access this fluid cube, so I can say fluid cube, and that'll now work. So solver. If I didn't have the exact name there, then it's going to error out, but you can see it's actually in the fluid cube. Now, the reason I'm making a structure is because this has to be basically an object. I need it to be all self-contained. I need it to be... I'm basically doing object-oriented code here. And object-oriented code, if you don't know what that is, it's very procedural. Let's say that we have a definition of a point. What that would mean is that every point will have a p-value. It's already given that. But it also has the ability to have extra things added to it, such as velocity, color, normals, etc. And so when I'm making a structure inside of C++, so a quick background on C. So C was made first, then C++ basically came over and gave it object-oriented code. Now C had technically had a form of object-oriented, not really. And inside it had something called structures, which what C++ uses as well. But you may have heard of the term classes. To the best of my knowledge, the only difference between a class and a structure in C++ is how the variables are exported. And the only way that they're exported is if they're so by default, when you make a attribute, so let's say a float, let's say position. By default, in a structure in C++, this is public. You have to actually set the keyword in C++. You have to go hashtag private. It'll error out because this is not C++. This is just standard code. But inside of a class, if you want to have some attributes public, like this one is, you actually have to define it as being public. That's the only difference between that. And the reason I'm making the structure is so that I can basically hold one thing like this forever. Unfortunately, we can't export it out, which would be absolutely brilliant to export out. So it's an undefined reference. It will be nice if we can actually bind it out, honestly. So let's go auto bind by name. And we're binding, let's say, fluid cube. Oops. Like so. No, it's not going to bind that out. It would be really nice if it would, but if anyone knows how to do that, that'd be great to know, because then this will make my job a lot easier. Instead of having to do all this, it'll actually just bind it out for me. So I'm going to say auto bind by name. Okay, I don't know if inside here we have a structure. So we have a struct inside here, I suppose, which isn't really what we want. That's not a struct, that's something else. So let's go back up. We need to give it some variables. And I'm going to basically try and reference from this, the real-time fluid documentation, which should be in the link in the description. But this was done by Jos Stam in 2005, 2009, I think. There should be a date on here somewhere. But basically, it explains the physics of the fluids. It explains how it's made. It's an implementation of the Navier-Stokes equation, which is what a lot of fluid systems run on. And if we go down, we can see, keep scrolling down. So he's just explaining different vortice and velocities and stuff like that. and val step. We're not going to get into that really, but somewhere around here, he has an actual implementation of it. So let's try. I might have the wrong link. Let's try and find the correct link. Dummies. Here we go. So I'll actually add that to the. Can I edit? Yes, I can edit the thing. The description. Okay, so I've edited the description. There is a documentation online which is taken from this documentation called Fluid Simulation for Dummies by Mike Ash, and he goes over a pretty basic method of creating this entire thing. Now, inside here, he's talking about. So let's go over this one. So this one's by Mike Ash, and inside here we're going to see a few things that we may not know what they are. It's fine. So he's done something here called define IX, and he's got a reason for this. It's saying it hates multi-dimensional arrays, and multi-dimensional arrays are basically how do I put it? So if we have an array inside here, so we say int is equal to, let's say 0. That's not working. Okay, so now we have an integer array of like, it's got 0 in it. This is what we have as a one-dimensional array. If I keep adding stuff to it, it's still one dimension because we're only in one-dimensional brackets. If, however, I do 2 dimensions, so I go like so, now this is a multi-dimensional array. VEX cannot handle that, and I'm really hoping for the day that they actually can handle it, but for now, it can't. So we're going to have to figure out how to do one-dimensional arrays, which is great because that's what the documentation goes over. So if we go back to it, so we need to define a structure, which is what this entire thing is. And the structure is kind of what we're going to be basically implementing inside of the extra code that I have there. But I'm also going to take notes from my tech art project here, because that way I know exactly what I'm doing and so on. So what we want to do first of all is I'm going to start by implementing the overall parameters. So inside of my, if you want to take a look at my fluid solver, it's there in the description. So I'm just going to copy and paste the first few stuff here. Oops, I'm going to explain them. So inside here, I've got private static n, scale, and iteration. So iteration is obviously how many iterations it goes over. The scale is basically a scaling effect that we can have to scale it up and scale it back down in terms of the size. And n is the resolution. We're finding it as a size. So 256 means it's going to be 256 points in the x and 256 points in the y. The private static part just means that I've made it private so that I cannot edit it outside of the script. And the static means that the code itself cannot touch it. Unfortunately, we don't actually have that inside of the code here. So I need to do something about that. So I'm going to take these off. And they should now just all work, basically. So now we're going to have an n. I'm actually going to turn these into channels. So I'm going to say channel n, channel scale, and channel iterations. So, and I'm going to set them to the defaults, which was 4, and 256. And I'm actually going to expand this one to be about 1024. So that's how high I'm going to be able to go in the future. So let's take a look. In here, I have two specific. So inside here, I'm also defining an overall global fluid, which is going to be this fluid cube. So I'm going to say fluid cube. Let's say fluid cube. Let's just call it fluid. And because I am initializing it technically in this first frame, so I'm going to have to export all the attributes later. So I'm going to have to export the end, the scale, the iteration, so on. I'm going to have to try and figure out how to export them all later so that I can put this into a SOP solver. Oops, wrong link. I need to make, if we go over here, I made this one global. So that way, these specific ones here, these specific voids actually take into account the this will actually take into account the whole the fluid that I've just been given. So let's just do that quickly. So this is, I'm going to actually hit Alt E and we're going to go into here. It's a nice big one like that. So I need, first of all, to do two functions. First one is the add density. The second one is going to be the add velocity. So what I'm going to do is I'm going to say void add density, because I don't want to change anything. The only thing that's going to be changed is the fluid, which is outside of here, which I'm actually declaring above here. Or alternatively, I could actually set the fluid back. So I would say this is a fluid cube void, and it will actually send it back to me. So I'm just going to keep it for this for now because I'm not too sure if it'll work. So I'm going to say int x, int y, and then float amount. So what this is going to be doing is it's going to take in an x and a y coordinate. The x and y coordinate is the coordinate of what point we're going to be going on, and the amount is how much we're going to be adding to it. So now then I want to say int index. So this is the index that we're going to be going over. I'm going to call this array index because that's the function I'm about to create. I'm going to say x and y. And then I'm going to say fluid density at the index plus equals the amount. And when I hit apply, it's all going to error out. So the first thing we need to figure out is this array index. So if I'm going to go back to my code and I'm going to look at my definition, and now I have a array index here. And the array index that I made was actually inside of the fluid cube in itself, and it's all this whole thing is actually in just one giant system. However, because I can't put the struct in here, I'm going to have to keep it like this. So what I need to do is I'm going to keep the struct in here only, and I'm going to keep all the code up here. And inside of C#, I could put functions below and above each other. It didn't matter in what order they were in. The problem here, though, is that we're working with VEX, which is a form of C++. If I don't declare the type, or if I don't declare it beforehand, before it's being used, then it's going to error out because it can't see it. This is basically C++ in a nutshell. We get around this in C++ by having something called a header file. However, I cannot have a header file inside of here because we're working with VEX. Okay, so what I'm going to do is I'm going to do this array index thing. I'm going to put it right above everything. So let's go back to where I've defined it. Okay, so I'm going to put it, because I don't need to know anything except, oh no, I actually do need to do the end. So I'm going to put it below everything, but above this fluid cube here. So I'm going to say this is an integer because I'm going to be given back an integer of this. This is going to be array index. It's going to take an int x and an int y. And honestly, I can just hit accept now, and then we're going to get one error gone, which is that one, because now it's been defined, but we're going to see it's not returning a value, so I'm going to say return 0, just so that it doesn't complain. Okay, so we've got around that. Now we need to do this fluid density part. But let's finish off the implementation of this array index first. So the array index takes, so x is equal to clamp, so I'm going to clamp it, my x value between 0 and n minus 1, which is why I now have the n above here, because then it should take into account that n. It's not taking into account the n. That's brilliant. You know, I love it when this sort of stuff happens. So I need to then say y is equal to clamp the y by 0 by n minus 1, and then I return the x plus the y times the n. And it doesn't like it because it's not accessible in this function, which I'd love to know if there's actually a way to make it accessible. I didn't copy it for some reason, so I'm just quickly googling inside for Houdini. Houdini VEX. So I'd like to make it a global, basically. So apparently it's not quite able to. However, what I can do is I can do something called a define. And we had this, or we've already seen this define method inside the documentation that I showed before, where we say define a particular function. Okay. So if I say, let's see if I can do define. So if I say define n is equal to n. Oops. I don't think that'll work. What was the error that has come? Unexpected end of file. That's fair. So if I actually set it to about 4 here, if I say n is 4, then maybe that would actually work. Yep, if I actually define n as 4 here, then I can do that. However, I wonder if I can now just say n is equal to this. Yeah, so it's a read-only attribute. So this is basically me making a static attribute here. So what I can do is, instead of doing this int n and the scale and this iterations, I can say define. I can just do these defines. So define scale is going to be 4, and define iterations as 4. So this one has to be 256 as well for the resolution. Okay, and I probably should have done that. There we go. Okay, and now we're going to say that we don't have a fluid cube density here. So let's actually define the structure. Yeah, so I'm going to go Alt E into here. Let's define the structure. So inside the where's my code? Inside of the structure, what we need is, we don't need that many things, honestly. So we need a size variable, which is going to be what our n is technically, but we need to define it in the fluid cube as well. And we can pass this down later. We need to find the time step, which is dt. Time step is basically yeah, it actually is called time step inside of Houdini, honestly. We need to say a float of diffusion. So it's a diff for diffusion, float visc for the viscosity. We also need to do a float array of s. I can't remember what s was. It's gonna really bug me. and a float array of density. And if I now just hit OK on that, then we should get something that's going away. And it doesn't like the fact that we don't have fluid. So what we need to do is, because I need to make this one correct, I can probably just say define fluid as fluid cube. What doesn't it like? Yeah, it doesn't exactly like it. But it's not going to give me a proper error for why. So I'm just going to copy that back there, and I actually need to pass in the fluid then. And there should be a way to export out my variables. If anyone knows, that'd be great, because I can't remember how to do that. Da, 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 Sorry, I'm just trying to figure out how to do that, if it's possible, because I thought it was. So you know how when we have this, when you look through the documentation, you have what's one that I can think of? If we go to, I think it might be this one. Yep. Okay. So XYZ dist. This one has these little and ampersand points in here. And what this one will do is it'll actually output the value that's coming in to that, which is what I'd really like it to do inside of mine. So we've got, if we go through the documentation, which everyone's going to be looking through anyway, so we've got user-defined functions. You can overload functions of the same name. So overloading is basically if you say void print and void print, but you have two different types of inputs, then it's going to, it will automatically select which one it needs. So recursion doesn't work. Parameters to use functions as a reference. The const keyword. Okay, so this is a shader, but I don't know if it will actually work. Let's try that. Let's just do a quick test. So if I say wrangle here, and I say int a equals 0, and I'm going to make a function. So I say function. I'm going to say void nothing. It's going to say int x. And I say x plus equals 2. Then I'm going to say print a. Print fa, I should say. And it's not going to like that because it needs to be a integer, a string, sorry. So I'm going to say sprintf. Actually, no, I'm just going to say I to a, which is going to turn it into a string. I'm going to say it's 0. So let's say nothing a. And it is actually returning that. So maybe it will actually work inside of here then. fingers crossed. So what we can do is inside of here, I'm going to hit accept, and it's not going to like anything because there's fluid density. So what I can do is, before anything else, I can just say fluid cube fluid, and that should hopefully work. It should refer to it, and it should read back, and it should set its results to that, like how it did with the other wrangle here. So let's keep going. So we've got this add density void in here. I'm going to press Alt E again, jump back into here. Now we need to have, so we could probably just put this right down here. We don't need to declare it just yet. Hit apply. We now need to add velocity. So I'm going to say void add velocity. This one's a bit easier. This one's basically the same. We're going to need to have the fluid cube again. Fluid. We need to have the current index that we're going over. And we need to say what, if we're because we're putting in a 2D vector, we need to specify which is amount X or amount Y. So I'm just going to say amount X and a float amount Y. So honestly, I could just say vector 2 into there, but we'll handle that later if we need to. Yep, still working. Cool. So the add velocity is basically the same as this one. So I'm going to copy and paste it. It's going to error out again. Why is it erroring out? So the amount, because we don't have the amount here yet. So I need to say amount X for this one. And instead of density, I'm going to say VX, which is going to be the velocity X. And then I'm going to say velocity Y as well. Velocity Y. That's going to error out again because we haven't defined these VXs down here. So I'm going to actually finish off the definition of my fluid cube. So what we need is, we've got the S, we've got the density. We need to have a float Vx and a float Vy, which is our velocities. And then we need to have the previous velocity. So we're going to say float Vx0 and float Vy0, sorry. These are just going to be arrays. Hit accept, and now that should all be happy. Yes, it looks like it is. I'm probably going to be losing people. I had 6 people a minute ago on the viewership. So I understand that this is getting a little bit complex very fast. I'm going to do my best to explain the VEX that I'm coding, but the explanation is so much better in this link here, as it explains exactly what's going through it all, and so on. Like, it has a creation step. It has destroy. We don't need to destroy us, thankfully, because destroying is basically it's freeing the memory. We don't need to worry about that. It's got we've got the add density, which is what we did. So we had the we got the n value. I don't know why it wants to get the n value there though. That's a little unusual. And the add velocity part as well. So that's all we needed there. And now we've got to have 3 main operations, as you can see here. In our fluid step, we basically initialize our entire thing, and we have a diffuse, and a diffuse, and a projection. We then have an advection, projection, diffusion, and advection. So if I want, so we've got add velocity, add density, and this part here is what's going to be added every step. So let's have a little think about how we can actually export these values. Because some of these functions can honestly be taken and split into their multiple different things here. So what I will do, no, okay, so I'm going to do this all in one solver, and I'm going to use a loop to loop over it inside the code itself, which eliminates the need for me to use a stop solver. This may or may not work. Everything that I've been talking about may or may not work, but we shall see. Okay, so we've got a fluid cube perfectly initialized. Let's keep going with my code here. So in my code, I do an update, I add a density, and then I do a fluid cube step. So let's go down. We need to do a fluid cube create first and a fluid cube step, because if we go up to our start, we have a fluid cube create. So let's just make our fluid cube create first. So inside of here, I'm going to say fluid cube is fluid cube create, which is 0, 0, 1.1 f. That's going to error out. So what I need to do is I need to say fluid cube dot that. And I did this in the older code where I initialized it. But it's a little harder to do. So what we need to do is we need to say fluid, and it's not fluid dot. We have to use a syntax from C++, which is the hyphen and the arrow key, basically. And that's going to give us this function in here. And this function only needs to be initialized once. However, the reason I'm doing it here is because I need to actually initialize those values at the start, and that's what will be given. So let's go back to my tech project here, go to fluid cube create, jump down to where it's just created, and we need to basically initialize it. So if I say printf fluid, it's not going to like it at all, because it needs to actually be stuff. So I'm going to say let's give me the size. That's going to be an I to A as well, because it's a integer. Nothing's going to come about that though, because we have to create this fluid cube create function first, and I'm actually going to create it inside here. So inside the structure, so I believe I can either put it here, or I need to put it above. It might need to be inside this entire thing anyway. So let's put it in. Let's put it inside this. Actually, no. We might need to put it inside here. Okay, so let's go fluid cube init. We're going to initialize it with an n value. We're going to initialize the time set value. We're going to initialize the diffusion amount, and we're going to initialize the viscosity. Okay. So instead of this fluid cube create, I'm going to say init. It doesn't like that because it takes an integer, a float, and a float. And I'm only giving it an integer. Why am I only giving it an integer? What did I say? How did I define my fluid cube here? So, okay, in my fluid cube, I didn't define n, which is a little weird. Oh, that's right, I didn't define n because n was already there. So I do need to actually define n in this one. So I need to say, I need to give it n, like so. And now we're actually getting a value. What I need to do is I need to return my cube. So I'm going to say fluid cube. I'm going to say cube. I'm going to say new. I think I need to say new. I don't know if I can say new, honestly. Oh, no, I need to say this. So I don't even need to do this. I just need to say this. So I'm going to say this.size is equal to n. This.dt is equal to dt. That's coming in. So this part here is going to be this current structure, this current object, and we're setting it to n. So dt, so this dt is going to be this fluid cube structures dt. It's going to be this one, but not this one. To make that a bit more clear, I should say dt in. I say dt in. So hit play again. I'm then going to say this dot diffusion is equal to diffusion. This dot viscosity is equal to this dot visc, sorry, is equal to viscosity that I've come in there. Okay, so now that's there. I now need to actually resize these arrays to make them bigger. Honestly, I don't need to do this, but it's better to do this at the start. But let's check how I did it in C#. Yeah, I did initialize them. So basically I made if we take a look at it, I have initialized my arrays with floats and such. So I need to basically do this for every single one of them. So I'm going to say this dot s is equal. Actually, no, I can't actually do this. So I can't say this dot x, this dot s is equal to n times n. That doesn't work. It doesn't actually resize, it doesn't initialize it at that point. What we need to do is need to do the VEX function called resize. And it basically sets the length of an array, as it says there. So I'm going to say s is n times n. Hit OK. We're going to hit it, I get a 0 again. I should be getting more than that, because the reason it's coming out with 0 and it's not actually giving us fluid, I need to actually say return this. If hit apply now, then we're actually going to see that it is actually giving us a fluid cube at our correct size. Okay, so I need to resize this again. So resize the density by n times n. I need to resize. Oops, I need to actually say this as well. This is not going to work. I need to say VEX by n times n. Resize this dot VY. It's n times n. Then I need to do the same for the VX0 and VY0. So I could just copy and paste this. And say VY0 and VX0, like so. And that's done for the initialization. I don't need to worry about that anymore. That's only just done once and it's done. Okay, so now that we've got that working, I'm going to get rid of this printf function. I'm going to go jump back into this code here, and we're going to start applying more of the everything, basically. Okay, so now that we have our fluid cube, and we're initializing our fluid cube, we have this lovely little add velocity, add density. What we need to do is set. So if we go back into our documentation here, so we've created our fluid cube, setting it to 0.1 f on the viscosity, and this was just basically a trial and error thing that I did. This render texture is making something n times 1, so we don't have to worry about that for now. And if we keep going down, so we have a render, which is taking the fluid density and such. We've got a fluid cube, and now we have a fluid cube create, which is what we just did. Then we have these a whole bunch of voids. So we have voids. This is a static void. Static void means you can't change it. Not too sure why it was static, but we can't set anything static inside VEX, I believe. Let me quickly take a look here. So static. Nope. Cast. No, it's casting. So statements. Have it defined. So we've got like pragmas. Pragmas are kind of different to how things work within. Basically, they're like a channel float system, but they're a little bit nicer, and they're normally used for. But they're not used for VEX. They're used for something else. Normally, I've only ever seen them used in C++ and OpenCL. So I just want to quickly take a look. So we've got structs, arrays, strings, BSDF, which is something I've never seen before. So we've got all these different types. we can't technically output structures, which you can find inside structs to organize your code. It's a limited form. So inside a struct function, you can use this to refer to the struct instance that you've made. Struct fields, so variables, and you can do like an initializer here. I don't need to do an initializer because I've already made an init function. The only problem is you can't export them, which would be really lovely if we could, but we cannot. I'm also going to put my stream to the other. Where is it? Where's my mouse? I'm going to put it to the other. I can't. I'm going to put it to here so that I know and I can see what I'm doing sometimes. Okay. So now that we've got that working, good, and it's initializing it, everything. We need to make the steps that we're going to have to do. So I'm just going to copy paste the steps and I'm going to explain them. So inside each step, so let's say void, let's give like a void. So this is what's going to be run over in the for loop. So void fluid step sort of thing, and we're going to say fluid cube cube. I'm going to call it cube inside here so that nothing bad happens. Yeah, something didn't like that. No, it liked it. Okay, cool. I'm just going to paste in everything inside here. So I'm just going to paste everything inside here that we need to do. Hit apply, and it's going to be like, oh, I don't like this. And I'll try and why did that do that? Okay. So these basically we don't need to worry about. They're basically taking all this and making sure nothing happens to it, if that makes sense. And it's setting everything up properly. So what we need to do is we've got the cube, this fuse. I need to just invert these around. No, that was a 0 there, wasn't it? Okay. Hit apply, and it's going to error out again because it has no idea what all these functions are. But this is just so that we can see what steps need to be taken. So we need to diffuse. We diffuse it twice. Basically what's happening here is we're doing the x and the y coordinate. Then we're going to project these both over. And then we're going to advect it. So we're going to advect the x and y again. We're going to project it again. We're going to diffuse it one more time. And then we're going to advect it. Okay, so I'm going to hit apply. I'm going to hit accept. So these are all the steps I need to do to make it work. So I need to let's implement the diffuse on first, which should technically that there are two steps in diffuse. So let's jump back up, and I'm going to say diffuse. I'm going to put the diffuse right here. And diffuse I'm going to make it as a void. So say void diffuse. Inside here we need to have attribute of b, which is the current one we're going to be working over basically. We need to have a float x array, so which is what previous one will be. So this is the velocity, previous velocity, this is the current velocity, this viscosity, and this is the time step. So we're trying to diffuse the velocity out a little bit. Where was I? Yep. Okay, so we've got float x, and then we've got a float xo, and then we have the float with diffusion and the float with time step. Apply. I'm going to keep it like that so I can tell it's not erroring out. And what we need to do is we say float a is equal to the time step times diffusion times, just going to do brackets here, n minus 2 times n minus 2. So basically I am, what's the word? It's not multiplication. It's when you do a little up signal. Oh, I've forgotten what it's called. Yes, we're squaring it. Thank you. Thank you, brain. Once we've done that, we need to say linear solve. And I'm going to say B, X, so that's B, and X in here. So newly created A, and then we just say 1.6, 1 plus 6 times I. I can't remember why we did that. Let's actually look into the documentation. So we have the diffuse, so let's go down to where our diffuse one is here. Pre-calculus value and passes everything off the linear solve. Thanks. So that means while I know what it does, and only how, since all that work is in this mysterious function. Cool. I actually need to figure out what is in linear solve. So here's linear solve. It's mysterious. Thank you a lot. So let's actually look at the documentation, shall we? Why can't I actually view linear solve? Linear. So if we go to our, okay, so we have a diffuse here. Interesting how we can't actually figure out where it is. So what diffuse bad. So he's talking about different types of code here. Got the advection, got the density step, which is what we're going to do in the actual step process. Got the projection and the simulation. So it doesn't really tell me where the linear solve comes from, which is really annoying. I would really love to know what that linear solve actually does. And the fact that it's mysterious to both myself and the person who wrote that article is rather annoying. Okay. So now we've got that, we need to actually make the linear solve function. So I need to put this above everything. Actually, I can put it above. I can at least put it above the diffuse. So I'm going to say void linear solve. And then I'm going to say B. Oh, wait, I need to actually figure out what linear solve it's taking. So it's going to take an integer B. It's going to take a float, again, of X. Basically, we're going to be giving the same parameters here. So let's say float XO, float A, and float C. Okay. So now we've got that working. Now we need to actually do our solving. So we need to. So what I'm going to do is I'm going to say float C receipt. So this is basically like a time step, if you will. So I'm going to say 1.0 divided by C, and it doesn't like that because I didn't say float properly. And now we need to do a series of 3 different for each loops, which is rather annoying. So what I'm going to do here is I'm going to say for int kk is equal to 0. Okay, so this is how many iterations it's going to go over, basically. Divide less than iter, kk plus. And you're probably wondering why I didn't use I, because I'm going to be using that inside. So I'm doing a nested for loop, but two nested for loops. So the first one here is going to go over, is basically how many iterations we're going to go over it. The other two here is going to be the X and Y position of our grid. So the 256 by 256, it's going to go for each grid of X and Y values, and it's going to give us what we need. So let's say this one's going to be JJ. This one's going to be double I. And the reason I do double I instead of just I is if in code something like this, and I have actually done I here and J and I, which is really stupid of me. But if I was in this massively long piece of code and I went Control F I, you can see that I am now looking for 441 values. If I say I, then I only have 5 values, which is here. So as you can see, I've actually done it here. It makes coding for loops a lot easier, and it's something I really recommend. So now that we've got these 4 for loops, after this KK here, I'm also going to do another function. I'm going to say set bound. I'm going to say b and x. And we'll get into what that function is later, but I'm just going to comment it out for now. Okay, so with this one, I need to figure out what my array index is, and I need to place that into my x value. And what I need to do here is I need to say x of my array index of I and j is equal to, I'm just going to put that for a second, is equal to, this is kind of a long one, so I'm just going to copy and paste it. If I hit go, it's not going to like it because I've got a lot of undeclared variables. That's fine, but I'm just going to make it longer, like so, or better yet, I'm just going to go like that, so we can kind of see what it's doing. And I'm going to put that down here. Yep. It's still not going to like it because it doesn't have I and j, so I need to just quickly replace the i's and j's here. J, I. If I hit apply now, what's wrong? What don't you like? Because they're on different lines, doesn't really like it, so I need to actually put them all on one line, which is not going to look nice. I believe there was a way to do it multi-lined. Let's take a look. Multi-line. Yes. Houdini. Is there any way to use multi-line expressions? Nope, that's not what I wanted. Nope. And nope. Doesn't seem we can. So this all has to be one giant array, which is really annoying. Function, I mean. Where did the rest of it go? I'll try and space it out so it's a little bit easier to see. Hit apply. Some things it still doesn't like, so let's figure out why it is. Doesn't want to plus an internal compiler error. What? Plus a, which is the float of a. Okay, that's a little annoying. I did write it out in the other one. So let's take a look to see what I might have done wrong in my other function here. So let's go up to linear solve. I'm not getting the correct. No, and is there. So I'm going to just comment this out. And I'm going to try again. Alt E. Okay, let's go. Let's try this again. So I need to get the x value. So I'm going to say x of my array index of II and JJ. Let's make sure I can actually set a value. Yep, it's fine with that. So what I'm going to do is I'm going to say put these all in brackets. I'm going to say times my C receipt here. Looks like I might have done something wrong. So I'm going to say X of my array index of IIJJ. So, nope, like so, plus A. That's going to error out, I think, because I just did something wrong. What did I? No, no, something went wrong. What's wrong with that? To receipt. Oh, right, I misspelled that. Alright, so I plus 1, sorry. I need to actually say plus 1 here to follow this. Apparently I don't, according to this one. Apparently I need to do XO instead of that one. So let's go XO. II, like so. Hit apply. No errors. Cool. That was plus A, and then I need to do another brackets, which is going to be times. Inside here, now I'm just going to copy and paste this. This one needs to be an XI. Now this one's going to be plus 1. Hit apply. Does not like that. Doesn't want to be timesing that by that for some reason. Huh. Doesn't want to what? Why doesn't it like that? It's array index. The array index is int x plus int y. I say plus plus. So array index plus plus is going to hopefully it's going to say plus 1. I'm not too sure if it will do that in this iteration here. Okay, so plus 1, and then I need to do minus 1, so I need to say plus this minus. I'm just hoping it's not actually going to be setting it to that, so it shouldn't be because it's not a void. The function isn't a void at least. And then I'm going to do the same thing again, and one more time, except for this one. I'm going to say minus here, and this one is going to be plus on the J here. So I'm not too sure why my plus 1 was not working. That's very, very annoying. And I've just mucked that up. Why did I muck that up? So it's that for loop. That's that for loop. Okay. Alright. So that's the linear solve equation done. The linear solve equation is quite hard to implement. Always was when I started doing it. But now it's looking good. So that's my diffuse done. We've got a fluid step. So if I wanted to say diffuse, I can now say diffuse, like so, and diffuse. Alright. Let's go on to the projection. So the projection is also kind of big. Unfortunately, the advection is the worst, which we will get to later. We've also got the set bounds. Let's implement the set bounds first. So I'm going to hit copy. And this one needs to go basically here, above my linear solve. Alright, let's jump in and let's fix up this code. So first of all, I'm going to do is I'm going to remove this static void. I'm just going to say yes, it is a void. I'm going to hit apply. Still doesn't like some things. Reckons some stuff is missing. And that would be the fact that this needs to be right here. Still doesn't like a few things. Alright, because this needs to be this can't be a comma, it needs to be a semicolon. I have got messages from Francis, Opdigits. Hang on. That's a good question. Opdigits in the VEX. Just asking about opdigits and how they work. So what doesn't it like? It's got a read only and read write expression. Okay. That would probably be this. So let's actually do it inside here for now. And I'm going to comment all this out. Wow, it doesn't comment out like it used to, does it? Oops, I pressed that, so I've forgotten how to do some stuff. So Shift Tab, right? Shift Tab, yep, Shift Tab. Void, int B, and this needs to be an array here. So I can't answer all your questions, Francis. Join the stream if you want. So why doesn't it like that? Let's take a look. Let's comp these out. See if that is actually the issue, and it's not the fact that we're minusing n. No, it still doesn't like something. It doesn't like this. This needs to be on one line. This needs to be on one line. This also needs to be on one line. As does this one. Okay, now it likes it. So let's reopen this one back up. What doesn't it like? It doesn't like this for some reason. So this is a one if statement. So let's go back to my old VEX code here. Let's rewrite it. So is x array index of I 0 equals 0. Let's just say that. I need to actually set this to be II as well. And what's it saying? Read only expression on left side of argument. So x is apparently just read only. Why is it read only? That's a very good question. Let's show 21. Some things it doesn't like. Alright, so we're going to get rid of this as well. So this array index, I think, is because it's using n by default. So what we could do is we can make everything not use n, but we do need to make everything use n. So instead of this define n, we'll put this out, and I'm just going to put this back to n like that. And it's not going to like a lot of this stuff. So where doesn't it like it? Variable is not accessible in all this. Not all code paths in the function return a value. So this one doesn't return a value. So let's actually say int n here. So that means we now need to say int n like that. But we also need to specify, hey, give us integer of n. Okay. So int n, say int n. I think this is because it was not exactly accessible. So let's go like that. Let's say, yep, this one also needs to have the int n here. Int n. I'm just going to add it to the end of every one of them too. This one needs the int n. Now I need to say n here. Basically, I just need to fix all these functions up. So the define, it's a pity it didn't work, honestly. Okay, and now that one needs the n as well. This one needs to have the n, so I'm going to say int n, like that. Linear solve now doesn't, it needs the n value, I believe, so n, that. Because this one needs the linear solve. So the fuse now needs an n. And what I'm going to do is I'm going to say int n equals cube dot size. So that's what it was. That's what we set it to. So when we set the initialization, we set the n to size, which is what we want. So I know to say n up here. That should now work. What doesn't it like? Declaration of n shadows a previous declaration at line 1. Where? Just trying to do that. Where though? Alright, so it's shadowing this, basically. Which is not really what we want, so I'm going to actually have to rename all these n's to something else. Just so that we don't get any clashes. So I'm going to say n in, or something better. So I'm going to actually put down, I'm going to put this one here as underscore n. Better to just change one thing. Two things, I should say. So that I know that it's a private variable, and so on. So now that we've got that, I can hopefully just uncomment these out. And give it the correct value as well. So I need to say int n, that. And these need to be double i's, because that's what we named them to. Okay, and now what don't you like? Doesn't like this. Why don't you like it? Read only expression on left side of assignment. Interesting. Let's try and figure out why that might be. Let's make sure it's not auto-binding anything. Nope. So we're going to have to try and figure out a way to set that array. But we should be able to set that array, honestly. So let's go int index underscore 0 is going to be the array index of I, 0, and n. So apparently it doesn't like that. So it doesn't like the fact that we're using this sort of thing here, so I'm going to say 0. Oh, look at that, it actually crashed. That's a first crash for us. Let's reload. Let's jump back to our VEX solver and continue where we left off. Okay. So it doesn't like the fact that this is going to be a specific number, because it likes to, for some reason, it seems like it actually changes that value there. So instead of changing the values here, what I'm going to do is I'm going to say int x, I'm going to say underscore x, and int underscore y, like so. Then I can say underscore and underscore here, like that. So then we shouldn't actually be changing that. So we could ideally just say define, turn that definition back on. Unexpected integer content expecting identifier. And I realized that I could probably just be taking that right out. So let's get rid of this. This one. Let's get rid of this one. This is n. This one. So now I realize why it wasn't working too well. Expecting this, so I'm going to say n. So whereabouts is the errors now? They are somewhere. Int n, yep, okay. So now these actually don't need this either. And we need to actually evaluate a few more things. So this array index no longer needs the n value. And this no longer needs that value either. So I need to be careful about using the voids, because they will actually just return the set value that we have been given them to. So I need to get rid of this n here. Need to get rid of this n here. Need to get rid of this n. That n. Okay. And I think that was okay. No, it wasn't it. This n here. A lot of this is just a lot of refactoring and trying to get C# code working in Houdini. If to whoever's watching as well, if you want to share this with anybody, do feel free, because the more people, the merrier. Makes me feel like I'm actually worth something. Okay, so now that we've got that working, let's set these back to being applied. I can now just hit apply, and that just work. I am just going to change this to a double J though, because I want to keep my semantics proper. Okay, apply, and now I need to do the same thing for this one, and that should now all work. So now we've got set bounds are now working, so I can now just say set bounds like that, and now that'll work. Don't know why that thing is open. Okay, let's take another look. So we've got the set bounds, we've got the linear solve, add density, velocity, diffuse. So now we've got the two big ones, which is the projection and the advection. So let's just bring over the projection first. Hit save as well. And I realize this is massive. And what we can do later on is, if we want to, we can put this into a .h file and we can just call it from there. So fluid step linear solve. So the projection needs to be below the linear solve. So I'm going to put it below the diffuse here. Okay. I'm going to just plug these back into each other, like so. Set bound, linear solve, yes, 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 yes. Okay. Now I need to do some fixing. So the first thing that needs to be fixing is these. So this needs to be, the array needs to be up here. This needs to be a semicolon. So, it seems these now work. So maybe I can put these down. So let's try that. Yep, okay, so that now actually works for some reason. It's really annoying why it works. Okay, so now that we've got the projection working fine, and we have the, now we need to have the advection. The advection is quite big. So the advection I'm going to put below the projection as well. So I paste it in. I'm now going to get lovely errors, which we can't actually figure out what those errors are for, because they're not standard VEX errors. So I'm going to go like this. I now need to change these floats around as well. So if you want a better explanation of what's going on, the coding trainer, I can't remember his name, Dan I think it is, does a much better job of explaining everything and why everything's working the way it is than I am doing. So this to do, that one I actually was already figured out, so I can get rid of that to do. So now let's take a look where errors are coming from. So this math f floor thing. So all we need to do here is, instead of math f floor, we just say floor. We just put down floor because that's an actual VEX attribute there. Got another error. We have another floor here. So this is an end float. What's end float? Oh, end float is up here. My bad. So this one's just going to be called floor again. What other errors do you have for me? No, that was it. Okay. So technically, it should now all work. All these functions should now technically work. So let's go back down. So we've got the fluid cube and we've got the fluid step. The fluid step has to be done every single time, so I'm going to actually just uncomment these. Add vect. Add vect. Okay. So now that's all done. Now I need to do it like a stepping program, stepping iteration based one. And the way we can do that is we're going to figure out how I do it over here, basically. So I have a grid function here. So let's quickly just Google that. Private grid, Unity. So it's got the grid system, procedural grids, grid. Let's figure out where grid is defined, which would be, so this is kind of cool in the sense that, well, GitHub's really good in the sense it can do that, but I need to actually figure out what grid is. So I don't believe grid should be an actual thing. So grid, get component, grid. So get component is a scripting API grid. Grid. Okay, grid is a base class plotting a layout of uniformly spaced points and lines. Okay, so basically that's going to make us a grid over the whole thing. So as you can see here, we've got int jj and int for the width and the height of it all. So what we need to do here is I'm going to make a grid. As strange as that may seem. I'm going to set it to 256 by 256, so that's going to be all around that. I'm going to then say I want to make a point in the middle of each primitive, basically. The way I'm going to do that, actually I'm going to face this in the ZX direction, in the XY direction here, like so we can actually see it. I want to convert this all into points, and I want to put the points in the middle. What's up, loud? Let me quickly. Will I have this saved? Yes, this video will be saved. I'm not going to go anywhere. I don't tend to delete the videos, and this is going to be public anyway. So I want to make put a point in the middle of the grid. So I'm going to go over every primitive. First of all, I'm going to say remove prim 0, the prim number, and then I'm going to say 1 to remove the points that go along with those primitives. I now need to get the position. So I need to say the way I can do that is I can get a list of all the points that the primitive is attached to. So I can say int points is equal. This is nice easy VEX here. So I can say prim points. So this one will turn an array of all the points on the primitive. So I'm going to say 0 at primnum. So then I'm going to make a vector position. I'm going to initialize it to 0. I'm going to do a for each loop. So I'm going to set int point over the points. For each is basically like a for loop. It's just a bit quicker to write, and I don't need to specify points by I anymore. I can just say point, basically. I now need to say plus equals the point of 0 position, because we're going to get the position of the current point that we're going over, point, and we're going to add it to the position. And I'm going to say add point 0 to pos. That's going to give us a false reading, but it's going to be much bigger. That's going to be about 40. If we wanted to get the correct one, we need to actually divide it by the length of the points in the array. So I say pos divide equal by the length of my points. And now, if we take a look, we've now got all the points there. One thing that I need to do here, though, is I need to make sure that I know where my neighbors are, I believe. But we'll get to that in a second. Let's just try getting some things working for now. So we have an update loop. So this is our update loop. So for int ii equals 0, ii is less than loop, and ii plus plus. And if I initialize that now, it's going to be initialized all the way down at the bottom here, which is not really what I want. So what I'm going to do is I'm just going to go edit parameter interface. I'm going to go to the bindings. I'm actually going to go to outside of my code. I'm going to make another folder here, drag it into here, and I'm going to say collapsible, just so I can collapse that extra one. I'm going to set the loop to about 10. And what I want to do is I can't really say, oh, set the current position of my mouse, and if I'm clicking onto it, then points. I can do that if I go into Python, but for now I don't want to. So let's figure out what we're going to do. So we're going to have, so for each update loop, we have to add density. We can add density to it. So I'm going to say if the point if don't really want to loop over every point, but I'm going to have to. Let's have a look. So I need to go for every point. I really don't want to. But I'm going to have to. So I'm going to say for int jj, or let's say point equals 0. Point is less than endpoints of 0 here, and then point plus plus. That's going to give me every point. I'm going to loop over every single point. I need to figure out if hmm what I need to do is I need to figure out where I really shouldn't need to do this, honestly, but I'm going to have to. So endpoints for every endpoint. This is where I really need help, by the way. If anyone would really love to jump in and help me out here, this would be great, because this is the harder part, getting it to work. So I've got all the code in there. It all works. The code's running. I say that very exaggerated, like, but it's more the fact that we need to actually get it running, working, simulating and stuff. So let's figure out. Should be an easy way. There should be an easy way. Let's just divide this by 2 so we get less points. Don't have to deal with so many points for now. And I can just say, yeah, just do 128, please. 128. So let's start out by just coloring something at least. Okay. So the way we can do that is if I want to make a circle in here, I can say I first have to get the position of my point. So I'm going to say vector pos. Vector pos is equal to the point 0 p of my current point, and I want to get the distance. So I want to get a sphere, basically. I want to get a radius. So the easiest way to do that is I'm going to say float f is the distance between a position and a set one, which I'm just going to set in the middle. Okay. Now then, I can set a threshold. So I can say if f is less than, let's say, 1. So if it's less than 1, then I'm going to set an attribute. So I'm going to say set point attribute 0. We're going to set the color doing the current point, and we're going to say set 1. We're going to make it just pure white, and I'm going to say set. Maybe that was a bit too much. How big is this? Let's actually put down the color first, and I'm going to set it just black for now. Okay, there we go. That's fine. So if I set it to about, let's set it to be about 0.7. So now I can say every frame add a density to that position there. So, just going to apply that at every frame. Add that position or add density there. So where is it? So I'm going to say add density, add density to the current position there, which is going to be the pos X, pos Y, and I'm just going to say 1. And it's not going to like it. I believe the reason being, so if I'll go all the way back up here. So I'm going to say add density, so I need to actually send in the fluid cube as well. And that fluid cube was created here. Well, I just call it fluid. Okay. What doesn't it like? So this it needs to be cast to an int. So I'm going to say int, like so. Cast these two as an integer, which may kind of screw up with some things, but that's completely fine for now. Now, why actually is it doing it? So at that current position, add density. So that would probably be why. So add density. Yep. Okay. Cool. So we're going to need to like remap this to like 0 to 1, based on the overall size. But now we have that working there. If that's there, then I need to do a fluid step, step, and I need to put the fluid into there. So that was the fluid step there. That's now it's actually running the entire operation, hopefully. For the amount of times I'm going to loop over. So if I say like 1,000, it should do like 1,000 loops. Finally, I need to render it. And render is not something I have got there. So with render, I actually need to send in the fluid as well. So I'm going to go like so. Fluid, void render, and so fluid cube fluid. Let's call this fluid. No, it's actually called cube, so that I'm not anything up. Not doing that. Send in the fluid. So I'm actually going to put this one down so that it's getting made right there. Okay. With the render part done, I now need to read the get the width and get the height basically. Okay, let me have a think. So, actually, I'll also download Unity while I'm at it, just so that I can showcase it working as well in the background. So, where's the download button? It's completely gone. Get Unity. Go here. I've got to download the Unity Hub, which is not something I'm a massive fan over, but it works relatively well. Yep. Agree. Yes. Install. I also need to clean my drives out a bit because they're getting quite full. Run, and I then need to sign in, I believe, which is rather annoying. Unity ID. Sign in. So I'm going to go over to here and sign in. Yeah, accept. Okay. I'm going to actually sign in with my Google account. Okay, and now that's signed in. Yep, allow. I'm sorry, this isn't part of the video. Honest, this shouldn't be part of the video. Accept. Activate new license because it's just a personal one. I don't use it in a professional capacity. Dismiss. Thank you. Cool. Activated in 2019. Groovy. Need to go advanced. Oh no, that's the preferences. So now I need to say installs, and I need to say add and install, and I can either get the official releases or the betas. I'm going to get this one here. This is not the alpha. This one's the alpha. You're not normally. You really shouldn't get the alphas unless you're really planning on doing something strong. So I normally actually do Android support, universal, and Windows build support here. That's all I needed. Yep, accept, done. And that should now be downloading and installing for me. Cool. But back to this. The reason I don't think it's going to work is because I've got a render texture, and the render texture is kind of handling a lot of the things in the background. So, let's figure out what my render texture is doing. No, I can't actually, because that's fine. But in the render here, I need to specify I need to get the density, and I then need to set the current pixel of that density. So, if I set density, I'm actually going to say, wait, no. So I need to get the width and the size of all the arrays and the points. So this should technically be the size, I'm hoping. So if I say for int I equals, no, let's say, yeah, I is equal to 0, I is less than cube dot size, I plus plus. Okay. I need to do another loop, so I'm going to say for int jj 0, jj is less than cube dot size, jj plus plus. Okay. Now what I want to do is get the current density of that. So I'm going to say float d for density. So I'm going to say cube dot density at this specific array. So I'm going to say this is 0, 0. So I'm going to say array index of jj, like so. And now I need to set that back. So what I need to do here is I need to say float den. So I'm going to say this is a float density. I'm going to say I'm going to say float here and say float float den sort of thing. I'm going to get rid of that, and I'm going to say this is going to be the den here, and then for each of these I'm going to say set point attribute 0 color of CD point of density by set. That's not going to be very nice, so I'm going to say set den by den by den. So that's just going to say, yep, it's all white. It says it might be uninitialized, so I'm going to say 0. Actually, I'm going to put this density right up here, so that it's this loop's not going to interact anything. Then what I want to do is I want to say, actually I just want to say I want to get the density. Alright, so this one needs to be underscore density, like that. And now it's going to execute all that sort of stuff. And let's see what's going to happen. either way, it's going to take a long time. So I'm going to hit escape. It's going to hit back to here. I'm going to set this right down to maybe by 4. So it's very, very small. I'm going to turn that off. I'm going to say 256 divided by 4. Still going to execute very slowly. I'm going to say just do one loop. Still taking a very long time. Let's do 4 loops then, please. I have a feeling the reason it's not really working is because this needs to be a value of like 1. So, and it's not getting the correct array, if that makes sense. So, I'm just going to go back, turn off the render part, and what I'm going to do is I'm going to set this to 1 by 1. I'm going to set this to 0.1, sort of thing, and then I'm going to hit render. And hoping it's going to work again. An email, security alert, thank you. Okay, yeah, so it's not really doing anything. So I'm going to go back to dark. Okay, no, I'm going to get back to light. I'm going to go back to my grey. Back to my grey. So first of all, what I'm going to do, because this was pretty good, all these I still need. I want to set them into a VOP sort of thing. So what I'm going to do is, let's take a look. I'm going to go to my documents. I'm going to go to documents. Element 5. I need to make a new folder called VEX. Need to make a new folder called include. Okay. And inside here, open the code. I need to create a new. Thank you. I need to create a new file. I'm going to call this one fluidsolver.h, and this is as I said, it's like a C sort of thing. Yeah, update it. Inside here, what I need to do first of all is I need to define it. Okay, reload. So what I need to do is I need to say if def, or if ndef, sorry, if not defined, and I'm going to say fluid solver test, like so. Then I need to do 2 more things like that, and then I'm going to say define this. So if it's not this, then define it as that. Then I'm going to say ndif. Okay. Now what I want to do is, so let's take for example we have this array index sort of thing. I can't access that here, can I? So let's just try this. Points. It doesn't like a few things, so what I'm going to do is, instead of this, I'm going to say int a equals array index of n by n, 25 by 25, like so. It's not going to find it. So what I'm going to do in here is I'm just going to paste it and set it back, and it's not going to like the fact that we don't have n, and also the fact that this now needs to be a, no, this one still needs to have all that. It's just not going to look right. I'm going to say define, or is it define or is it include? No, it's include. My bad. So I need to say include. Then I need to say what this file is, which is fluid solver.h. So fluid. That was on the other screen. So fluid solver.h. Now what? Invalid source. Cool. This could be because of this. Quickly reload. I may also need to specify this as a function. So it doesn't like it. So let's try another one inside here. So I'm going to say function int helper return 0, or let's go return 1, honestly. So I'm going to say helper. So, and that's going to return our current one that we want. So I'm not too sure why this doesn't like it. That is a little annoying. So what we're doing here is we're basically creating a VEX library. And we have something in here called the VEX compiler, which, if you take a look, we've got a VEX compiler basically. So it's just going to compile all our VEX properly. So we need to define all of our values and stuff. So let's take a look. We've got the VEX compiler pragmas. So pragmas we don't really need to worry about just yet. So you can see I've made a few more ones in here trying to figure out how to do that, essentially. Oh, that's Unity. It's finally installing. Terribly sorry if that kind of did something bad for you. So what I'm going to do instead of this, I'm going to jump back over to my include. I'm going to cut it for now. I'm going to go to my documents with projects, fluid VEX solver, and inside here I'm just going to chuck it in here, like so. And now, what I should be able to do is I should just say, so inside here it should now not technically work. So if I say int print f I to a, because it's an integer, it's now not going to like anything because a is not actually being given to me. So what I need to do is I need to say the job I could say hip, but I'm going to say job instead. I'm going to say job include that, and now we're actually going to get our value. Okay, so what we need to do is export these properly. So let's go back to my VEX fluid code thing here, and let's open some code. Okay, so I need to make sure that this array index actually works. So 0 by 0, 2, it doesn't like it. It's really painful. So let's go into where side effects is installed. Let's figure out how they do it. So inside one of these folders, not too sure which, there should be a .h file, like this. Let's go into the include, and you've got all these lovely little things like let's look for PC open. We've got Pyro, done with that. Well, let's try Pyro, and that just includes a whole bunch of other stuff. Really annoying. So inside here, we can see we've got these definitions. We've got these here, we've got vectors, so on. So instead of this, I can actually just set this to a vector 2. Honestly, I'm just going to turn off this function. Still doesn't like it, so I'm going to set this to a vector 2. XY. Still doesn't like it. Okay, cool. What we need to do is need to say x.x, or xy.x, and xy.y. So, and resume it, and it's still not liking it. It's very frustrating, honestly. Right, so let's say a vector 2, let's say set 0 by 2. Okay, that is just going to be frustrating the hell out of me. Why isn't that working? Helps that this is a clamp F. Let's make sure this is all correct. So we've got N, 1 there. So we know that this is working. Return of the int. This one was actually called a function, wasn't it? So we can say function. Still doesn't like it, does it? So vector 2. V. So I'm going to say V. Oh, there we go. Alright, so we can't actually declare it there because we could export it. Which is really stupid. Okay. That's actually going to impact quite a few things, honestly. Isn't close from float to int. Yep, whatever. However, let's just say set 0, 2. Does it still like it? Yeah, okay, that's fine. Cool. Doesn't like some things because it's casting from float to int because it's just defined as a float by default. But okay, so we've got that one in there now. So let's bring over the others. So I'm going to go to my solver. Let's take out these. And what this now means though is that we now need to actually give it the n function as well. which is really, really annoying. So I'm going to say int n. And now this one will no longer work. It shouldn't work. Alright. Yep, okay, it should no longer work. So I'm going to say put right, because that might need to be that way around. And it's still not working. Okay, so I need to actually cast this as an int, which is kind of annoying, but this is going to be an n, which is going to be defined value, so that'll be fine. Let's see if we can actually define some of these things. Nope. Okay, cool. So I'm just going to keep it as n. Let's say n between n and n. I'm going to keep making sure that that still works. Yep. Okay. Cool. Whatever. Don't know why it casts as that. It's kind of annoying. But okay, so that one now works. We may want to keep these two, honestly. But I want to take this set bound away. So I'm going to go copy paste it into here, and I can just say function. And now this should now export out my functions. So I now go, all right, I want to set bound to x and a. That's not going to work because we need to actually say something to that. So my bad. So I'm going to say x. So x equals 20, I suppose. I don't know. And it this is a float array of a equals let's just say set. Okay, it still doesn't like it. So why is that? So it needs to be a float array, int b, float x, so that they are ints. Let's say int. It should be working. Oh, this is gonna be like this every step of the way, isn't it? Okay, int x, array index, array index, and array index. So it should be calling the array index anyway. However, if I just comment this out, whoops, I just comment this out and I say, yeah, whatever. Why does it never like set down? Okay, so it likes that. But it won't like that. Because this array index is not defined above that. Ugh. Because this array index has been changed. So I'm going to say int x by int y. Cool. And then I'm going to say x by y. Don't you like? Let's go back to, let's make this back to be a function. The fact that it still doesn't like to do that is very frustrating. So let's go back. set found x and a, and it doesn't like it. Return 20. I think it's because it can't find the this array index function here, which is a little silly. So we need to go back to the definitions, and we need to define these as arrays. Hmm. Okay. Let's leave this to the side for now. How long have I been streaming? Let's take a look. I have been streaming for... Doesn't tell me. This will tell me. 2 hours. Cool. So, what I want to do is I'm now going to try and format some of this code. That's going to be a real tough thing to do. What I want to do is I want to change this from a int xy to a vector2 xy. That means I have to change everything, but I'll do that the last step, I would say. The fluid density, yes, it should be fine. Fluid x VEX should be fine. Now, has this been installed? Yes, that's been installed. Let me grab this TechArt project and I shall show you. Let's go to code, download the zip file, please. Just download to there. Let's go open it. Thank you. TechArt project. I'm actually going to call it, just rename it. So it is called TechArt project. And then I'm going to go down to Unity and projects, come on, projects, add, got to add to the project thing. TechArt project, select this folder. Unity version 2019. Dismiss, just play it, please. Play it. I'll select the version. Yep, firm, whatever. I've got a backup. Hmm. So let's just wait for this to load, and then we'll try and figure out how to make this work. No, ignore. So here's this scene. Could not find this, whatever. Let's go to my scenes. Let's go to my Navier-Stokes one. Come on, load. All compile. Oh, okay, all compile errors. Oh, that's an interesting. This could not be read. Why could you not be read? From assets, display JPEG could not be read. Innovation again, please. Unity editor, come on. My IntelliSense should be working, but it's not. Could not read asset from assets. So let's go assets from textures, sort of thing. So basically, it can't read this, which is a bit of a worry. So I'm just going to delete them because these we use for my texture bombing example. Okay, come on, clear. So this is used Unity script language. So don't know why that was there. So it's now loading it all up, and then it has a whole bunch of different errors. That's fine. Let's go. It's a little hard to say, honestly. But that's the fluid simulation working there. I believe I had a few separate things that I could use in my fluid solver here. So this just gets added automatically though. What I can do inside this fluid solver is I can say, I can do like a distance function here, but that's just why it's not so close. If I put this down to maybe like 128 or something, and then I hit go again, it should run a little bit faster, except my scaling's off a little bit, as you can see, so it's not really getting to the correct mouse position. So let's go back here because of this one here. This needs to be taken down to about half. So 128. So I would say 127 here. 127 by 127. And now that should work. Yep. It's not exact. You can see it's kind of weird looking. But this is what I want to try and get done inside of the Houdini VEX. Just that. Okay. So because it has like an array of all the points of like a thing, can I actually set this to like a render texture? So set to render texture. Actually, let's re-enable the render. Let it cook for a few seconds. Okay, let's actually check to see if anything has changed in that time. No, nothing's changed. So I have a feeling what's happening is this should be run over the points. So I'm going to turn this off. I'm going to run over the points. Oops. And I don't want it to go over the points here. I just want to say at ptnum. So, and then I could just say at cd is equal to at cd is equal to density. Like so. Hit save, load that up. Okay, yep. Cool, so it's not actually working still. So some people have already built some stuff in Houdini, such as this fluid solver built inside Houdini. Let's take a look at it, shall we? Previous work, pick flip related design, implementation. Let's go to implementation. So it's telling you how Houdini kind of basically works inside of here. I thought they would have an actual VEX implementation. Doesn't look like they do. So that's the acceleration. That's something else. Oh yeah, I already grabbed that one. What I actually want to do is I want to say Conrad's game of life. Conway's, my bad. Conway's game of life. Houdini VEX. So it's a little bit harder to implement this, I would say. So someone's already done it, which is great to see. But what they do is, if we take a look at it together, what they do is they basically go over quite a lot of. This is the Conway's game of life, by the way, which is a form of. I can't remember what the exact type is of what we're trying to look to. It's cellular automata. That's what it is. We want to try and do cellular automata inside here. And it's just showing some different examples here. So this is just setting it to black primitives, setting the ones, all these basically, just setting the groups and just setting them to a specific color. Then he's got the actual simulation part here, which if we take a look over, so it should be getting all the points, all the primitives, and doing like a neighboring to each other and so on. So if we take a look at it, it's got like all city values and neighbors +1, neighbors, sort of thing like that. So he's actually is using the neighbors, which is something I didn't want to try and do, which is like the get position part. So we're getting this prop. So this is technically working. The only problem here is that the pos x and pos y is being set to like an int. So let's set this to be about 50 by 50. Just forget that. Okay. And what I'm going to do is I'm going to set this to be, hey, are you above by about 3? Still not changing the color. Brilliant. Okay, so we want to try and do like a getting the neighbors sort of approach, which is honestly going to be pretty hard to do. So we go into position, point number, F density, add density to this fluid, to this pos X and pos Y. No, that should actually, that technically should be working regardless. I think the reason being is that we're not actually adding any velocity. So let's actually add some velocity to that. All I'm going to do here is I'm going to say, hey, add if f is less than 3, then do this. But I'm also going to say, hey, also add like velocity overall. So what I'm going to do is I'm going to say add velocity fluid, the int of position x, int position dot y, and what I'm going to do is I'm going to say so I want to try and figure out how to do this. So let's go to like my array thing here. I want to set all of them basically is just set up because this velocity is going to take like do like a subtraction amount already on it, which is not quite what I want. So amount x, amount y. Oh, okay, I see. So let's just say 1 to let's just say 1 to 1. So, like so. Let's re-enable it. Got to add the correct one, honestly. Still nothing. Still nothing. Cool. So let's go f. Let's say f at den is equal to the density. Where density is literally not being changed. Um. Hmm. But that should actually work here. Let's go back to detail. Let's go for blue. Oops, is equal to 0. Oh, sorry. Point is equal to 0. Point is less than endpoints of 0. Point plus plus, then we're kind of hanging ourselves up. Oh yeah, because I need that starting part there. Don't know why it's taking so long now. All I did was say add to it. It's a little scary, honestly. So why is it taking so long? Then it goes down, and then we're adding to that, but density. There, I think it's because we're doing it to the detail. So what I'm going to do is I'm just going to turn off this render. And now I'm going to say set point attribute again. 0, then point, then set. So, oops. Go back to here. Yep. And then I'm going to say point. All right, I need to actually say render too. So hopefully that's not going to take as long. See that some of these have now got a density, which is kind of cool, I guess. So I'm going to go back. That took a long time though. So I'm going to go back, and instead of density, I'm going to actually I'm going to say density. I'm going to hit solver again. I'm going to say color by ramp from attribute to the density. And I'm going to really pump that up, basically. So what I kind of want to do then, so that's by 3, and how big is this? 49.9, yep, okay. I'm going to say just do one loop, please. I'm going to say stop, please. Hang on. I'm going to say add point attribute. Oh, I can't. So I'm going to say set point attribute. So what I want to do first is I need to loop over this in an actual solver. So I'm going to say solver, and I'm going to grab this and I'm going to move inside here. And inside here, I'm going to say previous frame. I'm going to want you to run this over the previous frame. And now instead of this for loop here, I can actually say yes, run every time. However, what I want to do, I still want to run over all the points. I still want to do that. But inside here, so if I jump back up and actually turn this on, then it's actually going to solve. I'm going to hit stop for now. Inside here, what I want to do is I want to create a density attribute here, like so. And inside this density attribute, I now need to say, hey, get the attribute from the last frame. So I'm going to go like this. I need to get the density attribute from the last string, so I'm going to say float last den is going to be 1, sorry, then point at the same point, yes, and then I'm going to say den plus last den, sort of thing, like that, and then this way, in my fluid step, my fluid cube, I can then now just set the fluid. I can now just set the inside here. I can set what that cube is. So I can say last den is that. I'm going to say fluid dot density. It's going to be equal to last den. Like so, if that makes sense. Invalid from float to float. So, because yeah, that's okay. That makes sense because it's a float to float. What I need to do then is so let's add density. Let's just try not doing this for now. And let's just add the density to this density here. I don't know if it'll work. Well, nothing's been working so far, so it's kind of hard to say. I'm just going to jump out to here, and I'm going to hit go, and then I'm going to hit go again. So reset simulation, and I'm going to let it simulate. Now, if we take a look at our density, see some of these, I've got like, oh yeah, 45 sort of thing. So 45. Okay, maybe that shouldn't have been what I wanted to do. So let's take this out for now. I don't think so. It's kind of hard to think about this in the sense that how I want it to work, how it's not working. But we'll have to wait and see. It'd be lovely if this was actually a lot faster to solve. But as it stands, it is pretty darn slow as hell. So what I think is happening is this point part here is what we wanted to be doing over, but it's going over every single one, and it's saying for every single point, sort of thing. So what I want to do is I want to jump up, go into my color. I'm going to get rid of this color actually. So who cares about the color? I want to set these all to be like integer values, if that makes sense. And I want to put them all into an array. So I'm going to say attribute wrangle thing. I'm going to say int, no, yes, so at p.x is equal to, let's say round int p.x. I think it's divided by channel float amount times by the channel float amount. Oops. That may not be what I want. I want to gridify it a little bit. Okay, so let's say fuse, because I'm pretty sure there's a fuse option here. So it's got snap to points. I want to say snap to grid. Say grid spacing of 1. And honestly, so that means if I want to have 50 by 50 by 50, let's take a look at this. I want to fit these all properly. And what's happening here? It's solving the solver again. I want to set my X properly. So let's go to U. And I'm going to say X int, yes, technically. I can just say at p.x is equal to at p.x modulo an amount. That's not really working, is it? Oh no, at p.x is modulo at point number by an amount. And we can see what we want. We want to have it by 64, realistically. Maybe not 64. Be 63. And we need to do the same for the Y. No, we don't. Or do we? What am I getting wrong here? It's not that. Okay, so it might be for if at point num. No, hang on. Okay, so it might be at if at point num modulo my modulo amount, just my amount here equals, it could be, I think it's like equals 0, 1 or 1 or 0. Then I want to say at p.y is equal to 0. Not really what I wanted it to do. Let's take a look. So I want to basically fit this properly so that each one is like 1 by 1 by 1 by 1. So honestly, I can probably just say 100 by 100 here. Then we're going to have 50 by 50. Okay, so some of my family members are home. I'm just going to stop the audio for now, and I shall be right back. I'll put a note. Be right back. Okay, so I'm back. Let's try this again. I basically want to gridify this so that it's each one's like at a value of 1. So let's do a group. So you know how we can do like a group by range, and I can hold on. If we go to the primitive points, we can set it to be like a amount that we want. So if I go 1 out of every 50, I think is the amount. Every 64. Out of every 63, it would seem. Oh, that might be why. Okay. Let's try that again. So at p.x is equal to the point number modulo by channel by amount. So, and instead of, and I was going to do that to be y. No, that was not it. So if I just say, yep, no, I actually don't want to do that because then it's just going to be something silly. I had another way, which was using a line, where the line is so every one we do, so we say this times by that, basically. I'm going to set it to the the x direction, and then I'm going to do a copy to points, copy to points. So I'm just going to put that in there, except this one I'm going to transform. I'm going to transform it around one of these. Alright, so it might be this one that I want to transform. Yep. By about 90 degrees. Let's put in 0. And if I expand this, then we're going to get a greater and greater amount. So if I say 32, then this should be about 32 in diameter. Then I say add, and I'm just going to delete all the points. Delete all, delete all geometry. And then I'm going to plug this to my solver, and it's probably still not going to work, but at least now they're all there. So let's set this to 64. I'm going to hit back. I'm going to go back to you, and I'm going to say, yeah, this is 64. I'm going to set the scale to 1. Hit back, and then I'm going to hit reset simulation. And we're still getting this thing here. That's So I think it could be the fact that this is going over every point. But what I can do is, instead of going over every point here, I'm going over every point on this one. So I want to, as it says, I want to make an array, a twofold array, basically. And in each one, I want to set it on the X and the Y. So let's figure out how to do that. So let's actually because we're running over this just once, I can probably just go like this, and I can say, hey, for each of these. So as you can see, we've got this. What I would like to do is, instead of this, let's make a new point. So what I'm going to do is I'm going to say, hey, divided less than n. Okay. So for each point less than n, I'm actually going to jump up here and I'm going to show it in VEX. So I'm going to say attribute wrangle here. Point detail, I'm going to say, oops, I'm going to say for int I is less is equal to 0, I is less than, let's say, n, I plus plus. Then I'm going to say for int jj equals 0, jj is less than n, jj plus. Then what I'm going to do is I'm going to say vector pos. It's going to be set ii by jj, no, by jj by ii. So, and then I'm going to add point 0 pos. And then I need to specify what n is. So I'm going to say int n is going to be 64. And that's going to give us this, like so. And if we do that every single time, then what we can do is get the current point, if that makes sense. So I'm going to cut this, jump back into here, and inside here, I'm going to say, instead of n, I'm going to say, yep, this is just, whoops. What I need to do is I need to still specify the point. So, get rid of the pos. And then I need to do this, which is going to be this position by this, to see if it's within a certain density. If that makes sense. I'm actually going to set it, this is quite large, I'm going to set it between, let's say, and honestly, I don't need to do this now. So I can just get that, if that makes sense. But what I'm going to do is I'm going to say for every single point here, I'm going to say for like den is 0. Add point at the pos x plus y, add velocity to fluid. Then is this one, which is ii and jj sort of thing. But yeah, I'll put this way around then, so that we know what we're working with. Because no, yes, ii and jj, yep. Density. Let's put this somewhere in the middle. So this is 255 by 255. So what's 255 divided by 255, which is 125, I believe. So if it's like 125, 5, work. We're getting our cube density. Cube density is not even specified here for some unusual reason. Alright, so we need to say fluid density, not cube density. So say fluid density. Density is that. And we want to say fluid step, like so. Then I want to set that point attribute there, and I can actually get rid of all this, like so. Yep. Okay, so it's not adding to it, so it's not getting the one from every frame, unfortunately. So let's quickly check my other code to see how I did that. So density, let's take a look. Render at density. Between the render, fluid density is that. I think that's because the fluid density is just kept in the memory every time. So what we want to do is, first of all, I'm going to make this a lot bigger. So I'm going to say about 8. So I want to say, hey, get me the fluid density of the other one as well. So what I can do is I can say, hey, for get me the so I need to get a list of all the points first. So I need to say int points is going to be the point it's nothing starts. Let's say for int I is equal to 0, I is less than endpoints of 1. Because I'm making endpoints, and then let's say I plus plus. I want to just add points. Let's say append points by I. So now we've got all the points there. So now I can use this points array to get my current point, and then I can say point 1 den. So then I can add. Then I can add to that essentially. And as you can see, that's now working. So that's cool. We're now getting like this density just to keep adding to it. We're not getting our velocity, which is really annoying. So let's get. We need to specify. We need to put our velocity back in. So this one can be gotten rid of. Now, what I would like to do so I don't think that's quite right. This velocity at least here. So what I want to do is I want to get the velocity as well from this. So I'm going to say vector. Oh, actually, I'm going to say vector vector v0. I'm just going to give it underscore 0 float v y0 to be 0 sort of thing. This is going to be the last one. So amount. Where am I getting this amount? Just going to be that x minus y. So that should. So that's instead this, say int. Actually, hang on. So let's set a point attribute here. So I'm going to say set point attribute 0. I'm going to say v. So point. I'm going to say set. So we're going to say fluid dot. What do we want? We want let's say VEX. So I'll say VEX and fluid dot VY set. So it's not really telling me why can't I do that from float implicit class from float to string. No. That's a float. Okay. Let's go float VO. Float VO sort of thing. Ooh, what don't you like about that? Oh right, because I need to not give that. I want to say yvo is equal to fluid dot vo. Why don't you like it? Oh, vx, vx, and then I can say yo is for vy. So, and then I can say underscore vo underscore y, and it's not going to like it, so I'm going to say underscore o, or better yet, because I'm doing it like this, I'm going to say, hey, get the specific, get this one here, because I need to set this array here. So I can say vo an array this at this array, and I just did it twice. Brilliant. And I just need to say yep. So then I can just say yep v, and then I can hopefully visualize the velocities. You can see the velocities should be pushing it out to there. But it seems like it's not, because we're making a new fluid every step, which is initializing it to 0 to 0 to 0 sort of thing. However, it is adding to it. So let's try and think about how we can actually make it simulate properly without doing all that sort of junk. So we've got a structure here. We have an initialization, but we're initializing it every single time, which is not what we want. We want to initialize it to a default value, but we can't hold that default value over. So we're going to have to save out every single thing from this default value to the points. So to do that, so I'm going to say yep init. So I do want to initialize it, but in this fluid step sort of thing, I actually need to set it so it's resetting itself every time, which is not what we want. We want it to carry over from the next frame over, but we can't define a structure like this unless we actually make a VEX. So how about we do that? No, I believe my voice is going down. So adding custom VEX functions. Let's take a look at the VEX funds here. So let's go functions, signatures, casting, types of casting. Compiling, that's HDK code. Adding custom, adding custom VEX functions. Examples. Give me an example. So it has some examples in here, which is nice. So all this I don't expect you to really understand. It's fine. Here we go. why I wasn't really opening it. But what I'm looking for is a way to define a structure. So getting data in and out of this, and we have all this sort of stuff. Table context, let's look at the table context, image data, 3D data, channel data. Be nice if we could make like a new a new structure inside of C++, but we're not going to do that. Deep breaths. If we do like an if, so we have this if def and if def defined. Not really what we want. However, what I can do is I can set that. Now then, what I want to do is I want to say, hey, set point attribute, so set point attribute. And I'm going to say set, and I'm going to say fluid init. So I'm going to say point one, say set. So basically what I'm saying is, hey, I've set up the initializer for this. Now, inside here, then, what I can do, actually, instead of this, I want to say set detail attribute. For this one, I don't need a point. Just need to set that. So now we have a detail attribute of 1. Okay, now then, instead of doing that, I can say, hey, if detail of fluid init here is equal to 1, then copy all these values over, else actually initialize it. I'm going to say fluid equals that. But if it doesn't, then I need to actually initialize it again. So this time I'm going to make a new initialization function, and I'm going to set all the initializers, basically. And inside here, what I'm then going to do is I need to basically export all those. And I'm going to export them all as a detail attribute. So I'm going to set this one's going to be the size. This one's going to be size. Say fluid size. So I've got the size there. Technically, we don't really need that. This one's going to be DT, which is the time step. We're just going to keep it as 1. So this one is just going to be DT. Like so. Set detail attribute of diffusion. It's going to be a diffusion amount here. That. Set detail attribute of viscosity is going to be viscosity. And viscosity should be 0.1. And now, we need to do the S and the float density. so. That could actually take some time because I've set the wrong thing first. Also, we need to say it is actually S. I'm also going to go up. So stop initializing it. So I'm going to say fluid.s, set detail attributes, fluid dot density. So it's kind of a pain to export all these out, but it is something we have to do. So S, then I need to do VX and VXY. So then I need to set detail attribute 0. So this one must be density as well. VX is going to be fluid.vx is going to be set. And then this one I can just copy paste as many times because they're all basically the same now. So VY, and let's just get 0, 0. So, and now what I want to do is I want to say, hey, if it's not initialized, then if it is initialized, then just take these back. So what I can do here is I can then say detail. I can then just say basically I need to do this for initializing it, and I'm going to actually just put all these with an underscore so that I don't muck anything up. Honestly, I could instead, no, I'd rather do it this way, so that way I know that nothing is going to get wrong. Then I can say fluid equals, and I can do an overload here. Init. And it's not going to kind of compile, but what I need to do is I need to say, yep, fluid init. I need to say this.s instead, so I'm going to say this.s equals s. This.density, this.density equals density. So I need to say, yep, float, float. So this one is a float s, like so, float density, float vx, float vy, float vxo. It's also an array, float vx, vyo. I think that was it. And inside this, I now need to say, yep, is density. Yep. And I need to say this. So then I can just say this, and this. Whoops. Is equal to the incoming, so VXO. VXO. Whoops, that should be YO. VXO. VX should be equal to VX, and this should now also be equal to VY. And now, what I need to do is if I go back up here, I now need to give all these into my initialized value. So I need to say size, dt, diffusion, viscosity, s, density, vx, vy, vxo, and then v underscore vy. And if I now set down to auto update, I just want to make sure that I'm not getting any errors. What I need to do is I need to just get the detail of all those values. And it's taking so long because we need to it's setting all the detail attributes, which is really a long time. I'm also going to hit escape because I think it's crashed. Looks like it has crashed. So I'm just going to go around and close some of these windows as well. Okay, to jump it up, I want to stop to go back to the first frame too, so that it's not cooking, because I think it might be cooking all the frames. It looks like it's just trying to set all the points and stuff, which is really annoying. So the thing that's taking the longest is that array attribute, honestly. It's yes. And it's taking its sweet time. Okay, and we can see that it's now finally set those massive arrays. And honestly, it would make more sense to put these into the points themselves. So let's actually try that. So, but that means we can't access that here. So what I need to do is then I need to go, oh yeah, I need to do another one here, like that. And then I need to initialize all that. So I need to go here and initialize that, if that makes sense. What I need to do outside of this, oh, okay, so if, no, I need to put this, okay. Alright, so I need to put this here, I need to put this here. So, and instead of set detail attribute, I want to say set point attribute. So, I'm going to set this one to detail, but I'm going to set all these other ones to the point attribute. And set point attribute. And it's fine if these are like, what else I need to say? Point. So, otherwise it's not going to work. One thing we do need to do is need to set the arrays as well. So, because these ones here are arrays, we need to set them properly. So let's say point, and we can do that with the this array index part here. Point, point, this one to point, this one to point, this one to point, this one to the point, and finally this one to the point. And it's not going to like it, but I have set it to manual, so it's fine with it for now. But I need to actually set this to be like that, which is going to be this fluid site, this one here, 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 and this one here. Get rid of you. That's not going to work. So set point attribute. So we've got that, which is not really working. What don't we have here? So to float to int. So fluid VEX. Why is it not liking that? So this one actually does want to be a float. What doesn't like about that? Explicit cast from float to int. Whatever, but it's doing this thing. It doesn't like that. So instead of doing all this here, so I'm actually going to declare these up here as well, so that I don't need to go through each of these. I'm going to go back here. I'm going to say yep. So this float x vx here is actually just going to be a float. So I believe it actually might not like it, so I'm going to say yes, this is a float, this is a float, this is a float. These ones don't need to change, honestly. These ones do. So it's F, 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 because these are not going to change. Okay. And I need to say, yep, give me that. So, and I basically need to do the same for all of these. Just varying which attribute we're getting them to. So, fluid size, DT, DT is fine, but I can actually instead say DT here. The viscosity, that's going to remain the same, so let's say that's the diffusion, sorry, that's the diffusion. This viscosity is going to stay the same, so let's say visc. So this ray index here though is going to be instead, it's going to be this is going to be fs thing here. So we're defining what it is before we actually put it into here. This one needs to be density as well. I'm just going to set them all properly. So the x I, and yes, this is we're still in the very boring phase, trying to get this code to work. It's technically working in the same sense that it's still uninitialized variable visc. All right, what about this one? Implicit class and float to int. Set point attribute. Point set. No, it is literally a. I'll leave it as that for now. And it's still not really adding it to the right ones, it would seem. Oh, point needs to go first. I mucked that up. I completely mucked that up. Didn't I? Totally did. Damn it. What point wants to go first? I can't believe I'm such an idiot. Wondered why I was not liking it. So now I can probably just copy and paste the old code that I had. So it looks a little bit nicer. What doesn't like? Doesn't like point DT, that's fine. Diffusion. Don't mind that. So let's just say is fluid.dt, and this is fluid. That. Not diffuse. What don't you like? Cannot set. Oh, right, point. So set. I've accidentally added the point there as well. Get that point. Okay. Fluid. So then let's be fluid. Visc. With this fluid.s, I can just copy and paste this back in, and it should. If I don't add that, it should now all work. You can see they're now getting their proper density and everything. So, get rid of all that. And inside here, I want to initialize this. Say, hey, get these, please. So the size, the DT, the diffusion, the viscosity, it's not really changing. So I'll keep this to be the same. So this is going to be n by 0 by 0. Or, alternatively, I could literally get this from here. However, I don't really want to. So this one's 0.1 f. We can just say 0.1 or 0.1 f. It just helps. And now we need to actually initialize these free variables. To do so, all we need to do is go to here. So I want to say int point is going to be array index of IIJJ. That's going to give us a point. And we can actually, instead of doing that, we could say, so this is a float density here. And go like that. It's not right, so it's a point. 0. This, and then that's the point number here. And what I need to say is I need to get the density. Well, I need to get the S first. Let's get S first. Let's just say get S, something like that. Actually, instead of this, I can just say underscore S is going to be this. Like so. And I can do the same for every single point. So, so this, and let's say density, VX, VY, VXO, and then finally VYO. So this one wants to be density, this one wants to be the VX, VXO, and VYO. Did I set them correct? Yep, okay, cool. Jump back up. Still not really working. Really annoying. So, even though we're initializing it, initializing the detail and including it is then, yes, okay. I am now out of ideas, officially. We just set this here. What happens? Probably nothing drastic. Nope, nothing really that significant. So you get a density of 1. ETS is not changing. So let's. Where's my DT? Where am I sending my DT? Actually, DT. Fluid step. Where's my fluid step? Fluid step cube. DT is here. Where am I setting my DT? DT is down here. DT in. DT. So same fluid. The second one is this one. So let's just set that to 1. In my fluid init. Where's my fluid init? Fluid init is 1 and 1. So let's try another one. Let's try density. It's the same. S, nothing. X, nothing. VY. the hard. Okay, hang on. No. Let's take a look at the original documentation that we just had, which was this one. And I want to go to the fluid step, so I'm just looking through the code. Fluid cube step. Right, so what's happening here is these are being set to pointers, so these should technically actually not be what I've set them to. So these should be what I'm trying to set them to right now, which is all this. So I'm just going to get back a lot of this junk. So some of these doesn't need to be changed. And those would be the DT, the size, the viscosity, the diffusion, and the DT. But the density definitely does need to be copied over. So density. This density here. Mm. Okay, so that may not be it. That may not be the solution. So I'm probably going to have to leave it here. It's almost midnight. I normally go on way longer, but it doesn't look like it wants to kind of work. So that's always fun. Oh, hang on. No, okay. Doesn't want to work. So points. That. Yeah, so details is points. One is points. I don't think I need to do that points thing now, honestly. Actually, get rid of that. ideally that should be working now. It should be getting the correct, all the values from the secondary points here, and it should be advecting and diffusing and going through and all that sort of stuff. But it's not, which is very strange to me. So setting all the point attributes, yes, here. How about instead of this, instead of here, I'm going to put this in here. Get rid of that, get rid of that. It's going to error out, naturally. And I need to set this here. Then I need to, instead of doing that, I would say the fluid dot that. So I'm always going to be initializing it anyway. Doesn't matter. Always going to be initializing it. I don't need any of this anymore. But I do need to initialize it to the fluid properly. I don't think that'll work, but hey, you know, nothing else has worked. Let's add it to that then. See if we're writing it, because it could just be 0. Don't think that'll work though. So let's try and animate this. Between this channel float, channel B here, back. So, and in this one, I'm going to say 125 and 125, and I want to do like a sign of the $F plus 125, and the same thing here, except I'm just going to do the cosine. And what should happen is that should just do like a circle. Whoops, went too far. It's not big enough though, so I need to go times, let's say times 12 on each side, times 12 on each side, and then I'm going to times this by 4, so that's a bit faster. It's a little unusual, not really working. Let's go back to my GitHub. Wrong. Checkout project, assets, scripts. fluid solver, and I want to make sure that I'm setting the it doesn't look like I'm setting the VEX to anything, honestly. Which is rather disappointing. Also, this should be working a bit faster. So if I go to make a sphere, what should happen here if I do a transform? I'm going to copy that transform, and then I do a cosine. What should happen is that should now just move in a massive circle. So, but that's not really happening here, is it? I don't think the VX is getting set. So the velocity beforehand, basically. 0 S density, yes. Did I muck up anything? Let's go back to my fluid step. Fluid step. No. S, VX, VY. S density diffusion to 2. VX, VX, VY. Did I muck up my projection somehow? The projection was pretty quick. Let's copy the projection I did last time, which should be this one, which is going to be completely wrong. It'll be full of errors, but let's go to it. So this is this one, which is my project, and I'm going to turn this down. I've already gotten iterations here. Take a look. Why did I put that? Oh no, here we go. Yep. Visions. Apply. Still a lot of errors. So IX is the array index. Oops. So I'm going to go back to that. I'm going to go back to you. So IX is the array index. So array index. So array index. Array index. That. Apply. Some doesn't like it because of this n, because this was what I did beforehand. N, get rid of n there, get rid of n here, get rid of n here, get rid of n here, and n here. Apply. Now we have a few left. Less. Call to undefined function. Fluid step. No, it's right there. However, this one is set bound. So set bound. Yeah. Set bound. I don't need the n anymore. So just add this to the array x here. And we take out the n. And then I need to just do set bound. bound, and then set bound. Set bound, so, and then we have a linear solve. Linear solve. Yeah. Like that. Doesn't like something. Oh right, doesn't want end. Doesn't want these two. Doesn't need them. Back up. Let's turn the diffusion up. Actually. Turn the scale up. I don't think that would be it, but it could be. I doubt. At least we are seeing something. Where's my diffusion? Diffusion. Go down to. Oh, right, I want to say project instead of projection. I want to say project. And I want to say. Let's say 0.5 and use, let's say 1 and then U, instead of $F, I'm just going to say dollar frame. Yeah, at frame. I don't think that'll work. It doesn't like this because my project has extra. Does it? No, it doesn't. What don't you like? Unexpected at that. Where? Not very helpful, is it? Ooh. Let's divide that by 8. So 32 points instead. See, that's quite. Hang on. 32 points. Why is it still giving me a massive amount? Oh, right. Let's say 32 points. Let's say 64 points. Sort of thing. And that's not even going to go coming close. So 63, 64, 64 is 32. So 32. So 32 basically, and then 32. So like it's kind of moving, but I'm not even sure if that's just because of the points being that's just the way they're made. Um, I would love for somebody smarter than me to tackle this. Give the source code if anybody's interested into what I've been making. Because I don't know what I've done wrong, and it would be really helpful if somebody could tell me what I did wrong. said project last time, didn't I? Why did it not do my project again? It's still not setting the VX, the VXO part, and I'm wondering about that. I'm really curious as to why that is, because the VXO should have something. Back to VX, VXO. Okay, I'll send this to a few people, see if they can make heads or tails of this. Thank you for those who actually tune in, leave a comment and stuff like that. This is currently not finished. If I actually manage to finish this, then I will do a quick video on how to make it work and stuff like that. But right now it's just not working, and I am kind of lost as to why it's not working. We'll get there soon. Okay, sorry for that. Thank you.